The year was 1974. The satellite was Westar 1. The era of domestic satellite telecommunications was born. This beginning was, for the most part, unheralded, and but for an occasional via-satellite announcement during news or sports programming, went unnoticed by the public. But to a few individuals with the vision to see the potential of satellite communications and the courage to pursue this vision, 1974 was the beginning of the first decade of a new industry. Turner Broadcasting multiplied the viewership of an independent television station in Atlanta by utilizing satellite distribution, and the process created the internationally respected and profitable cable news network. ComSat increased its capacity for satellite uplinks by 800% in just 10 years. And Kaul-Tronics Incorporated of Richland Center, Wisconsin, grew in less than 5 years to become a leader in consumer and commercial TVRO manufacture and installation. Recognizing a market for reasonably priced, high-quality TVRO systems, including dishes, mounts, and actuators, Kaul-Tronics developed a family of products which met with immediate enthusiasm in the marketplace. Easy shipping, handling, and installation, plus unsurpassed performance, accuracy, and durability became hallmarks of the Kaul-Tronics name. Through its commercial division, Kaul-Tronics has installed dozens of systems in motels, hotels, resorts, and cable TV operations. By combining Kaul-Tronics produced antennas, mounts, and actuators with a top-quality line of electronic components and expert installation, Kaul-Tronics has shown commercial clients the value of satellite communications and the improved profitability that comes with offering satellite television. For the TVRO dealer, Kaul-Tronics supplies the entire range of products necessary to meet the growing demand for reasonably priced satellite reception systems. In addition to antennas, mounts, and actuators, Kaul-Tronics supplies receivers, low-noise amplifiers, IF filters, remote controls, feed horns, cables, connectors, and adapters. And to ensure efficient ordering and delivery, dealers use the toll-free 800 hotline when ordering from Kaul-Tronics. To improve dealer sales and service, Kaul-Tronics supplies dealer support products including advertising material, brochures, instructional manuals, catalogs, even a videotaped sales demonstration. In 1983, Kaul-Tronics introduced the world's first stainless steel hydroform TVRO dishes, the Nova SS Series. Now available in 3 sizes, 112-inch, 90-inch, and 66-inch, the production process utilizes a 1,000-ton hydropress to create the most accurate parabolic shapes available in TVRO dishes. Hydropressing eliminates the ridging effect caused by the spinning process used to produce other metal dishes. And stainless steel is noted for its rugged durability. So rugged, in fact, that Kaul-Tronics backs these dishes with a 10-year limited warranty. The process begins as 2 stainless steel sheets are joined together on a machine welder, then inspected to ensure a perfect seam. The sheet of steel is then shaped on the hydropress to form the low-noise, deep dish antenna. After hydroforming, the antenna is again inspected for accuracy. Then surplus material is removed, yielding a perfectly formed dish with the feel and finish that Satellite TV magazine has called absolutely superb, as smooth as silk. But the true test of any equipment in the TVRO industry is performance. And the Nova SS112 has proved its efficiency in independent testing conducted by Telstat Corporation of Houston, Texas. Telstat concluded, the SS112 proved to be a very efficient antenna at 64%. The antenna demonstrated good pattern integrity. The SS112 antenna system should perform at 2-degree spacing with negligible system performance degradation based on measured results. To better serve its dealers and meet the increasing demand for its products, Kaul-Tronics has established regional offices in Boulder, Colorado and Las Vegas, Nevada. And with its own fleet of trucks and service personnel, efficient delivery and professional assistance are part of the Kaul-Tronics quality package. Innovation has been at the foundation of Kaul-Tronics since its beginning, and research will continue to play an important role in the future. a new bearing mount for the SS-112 with circular steel rear support and commercial self-aligning bearings of oil-impregnated sintered steel in a housing of carbon steel and cadmium is now ready for delivery. And the revolutionary Nova SS-66, a 5-foot stainless steel antenna designed for 12 gigahertz reception, has demonstrated excellent results on 4 gigahertz signals. The Nova SS-66 fills the need for good quality reception with limited space requirements on roofs, in cities, in campers, where space is at a premium. With improved power on some satellites such as Galaxy, the Nova SS-66 answers the needs for a smaller antenna. It also carries Kaul-Tronics' full 10-year warranty. Kaul-Tronics will have the Nova SS-66 packaged and available for delivery at the shows in Las Vegas. Superior performance combined with easy installation and exceptional durability, a complete line of accessories, and a reputation built on quality and service make Kaul-Tronics the logical choice for consumers, cable operators, commercial installations, and dealers, now and into the future. Kaul-Tronics will be at the upcoming shows in Las Vegas, booths 18 and 19 at the Space Show, and booths 113 and 115 at the STTI Show, where you'll be able to see and operate their entire product line. Now, stay tuned as Kaul-Tronics brings you Satellite Preview 84.
Hello, and welcome to Satellite Preview 84. My name is Chris Schulteis, and I'm your moderator today. In real life, I'm the editor of Satellite TV magazine. And today we're gathered here with some of the key people from our industry, from all facets of our industry, to discuss the trials and tribulations we can all expect to face in 1984 in the satellite industry. The discussion will be informal, and we do have audience participation, of course, and the audience will have a chance to ask questions later on. I'd like to introduce our panel now. First, we have Taylor Howard, Director of Research of Chaparral Communications, member of the Board of Directors of Space. We have Peter Dalton, who is the President of KLM Electronics and also the President of Space. Mike Gustafson, President of Satellite Receiving Systems, consultant to the industry, and West Coast editor for Satellite TV magazine. Chris Kalmbach, Vice President of Engineering for TDF High Tech, and Jacob Inbar, President of California Amplifier. The satellite industry has come a long way in the past 4 years. In 1979, we had the first trade show, if you will, in Oklahoma. A handful of people gathered with some very crude and often basement-built equipment. Probably less than 1,000 systems were sold in 79 and 80. Where is it going to go in 84? Taylor, you've been involved in the industry almost since its inception. Where do you think it's going to go?
Well, I kind of object to the characterization of it being built in basements. I built my satellite system in my garage. That's literally where it started, and I think in 1979 we looked at the people we had at the show in Oklahoma City in 1979, which was the first one. It was mainly hobbyists. There were a few businessmen and quite a few that were building their own equipment, hams, other type of hobbyists, people bailing out from the Citizens Band radio business. We see quite a different character in it now. If you look at our panel, and as I talk to people that are in the audience today that were at our dinner last night, we see mainly responsible business people now. Good engineers, a few of the hobbyists left, but not very many. It's turned into a real consumer business, one where the businessmen and the engineers are looking at something very different from the hobby aspects of it. I think we've seen the equipment grow in sophistication and come down in cost an immense amount. It was just unpredictable a few years ago that things would cost this low and work this well. The changes in the equipment have been spectacular. I think that there's been some fundamental things happen that were unpredictable that have made what we have now, DBS at C-band, really happen. And that they're fundamental things in solid-state physics that have made it possible to get really low noise amplifiers. And we'll talk more about it in the panel, but I think this has driven the system. It's changed the antennas, it's changed the receivers, and it's certainly changed the way that all of us look at C-band versus K-band and the coming DBS system.
When we talk about DBS, of course, we're referring to a generic DBS that's 12 gigahertz, I assume.
Well, the direct broadcast satellite idea has been around for very nearly 20 years, and it's always been, at least in the international arena where we make treaties regarding the use of frequencies, it's been a 12 gigahertz game. That's changed in many people's regard now. It was thought the technology would drive us to 12 gigahertz. It's very clear that direct broadcast can now be done at any frequency we want, and in fact we have more than 100 channels of direct broadcast now if you accept a little larger dish size than the DBS people would have. The whole idea of DBS and the developments that I've been involved in since the early 70s is that you can have a system that will have a 1 or 2 foot dish and a few dollars worth of electronics and have very good television from it. It's always been limited in the number of channels that were going to be available. Nobody foresaw this thing where we would have the ability to receive at this frequency range and receive literally hundreds of channels. That was never thought of, and that's a surprise to the planners as well as to those of us who are engineers.
I think it was Ted Turner who said in Orlando at the space show that, hey guys, DBS is here, alive and well. And he was, of course, referring to the existing 4 gigahertz service. As the editor of a magazine, I receive a lot of mail from all kinds of people who don't own systems and are interested in buying them, people who have systems from dealers, distributors, manufacturers. One of the biggest problems that seems to concern these people today is the hoopla that has surrounded the proposed 2-degree spacing plans. My position is that the 2-degree spacing has probably been overemphasized and is not as serious a problem as was first anticipated. I think with the developments of electronics, antenna technology, and certainly the formatting of the satellites themselves, cross-polarity between adjacent satellites, that it will not be as big as a problem as perhaps we first anticipated. Mike, how are electronics going to affect 2-degree spacing and performance of systems?
Well, early on, the EIA proposed a standard of some number of dB carrier to noise or carrier to interference ratios, and that was based on a technology that's quite old. The newer technologies embodied in the KLMs, the Gillespies, the Earth stations type receivers are such that they are less prone to adjacent interference. They have a higher capture ratio, if you will. So a prior number that was used by the EIA of 20 years ago, before satellites really in orbit, are found now to be still valid as far as the absolute value is concerned, but as an operational standpoint, the number is dropped to the 12 to 13 dB range, which means that it will allow a lot smaller dish to operate. The current indications are that an 8-foot antenna is right on the line, and anything larger than that is going to survive the tighter spacing very quickly. Right now, that spacing is available for test if you'd like. If you have the fortune or misfortune of being either a user or a manufacturer on the East Coast, you have essentially 2-degree spacing between Galaxy 1 and Satcom 3 right now. On the West Coast, if you wanted to try to play around and see if your system will work, is G2 and Satcom F2R are on 1.7 degree spacing effective. The best place to be if you're going to want to run real small dishes is in Denver. There, because of the geometry, none of the satellites, even when closer spaced, are ever going to get down to less than about 2.5 degrees. That right there mitigates the situation considerably. The other concept is that people often forget that there are actually two different band plans, if you will, currently available on the satellites. The so-called Westar series and the SATCOM series, RCA Americom. These have what is called orthogonal polarizations, which means that vertical of one transponder is horizontal of the other. That gives you an effective isolation, if it's done right, of about 25 dB, which is more than enough to survive. So effectively, if you're looking at SATCOM 3, and Galaxy 1 will not cause a problem because it is on orthogonal polarizations. That is a very big factor in this. And the FCC is considering and being petitioned by many of the big companies to rethink their 2-degree spacing entirely, but notwithstanding any changes there, they're looking into having a little tighter control of which satellites go where. And they're trying to drop in, if you will, a opposite satellite in between two common satellites. That way, effectively, you're back to 4-degree spacing, even if they are 2 degrees apart. But because of the opposite polarization, it gives you the isolation. Unfortunately, the band plan, or the satellite plant, is already in place, and a lot of that can't be changed. They're there, and it would take quite a bit of rearranging of satellites. You just don't pick them up like blocks of wood and move them around. Hopefully, they're going to allow a longer, as the satellites die off and are replaced, they'll be able to have an effect that will indicate that in that slot a certain kind of satellite must go for proper operation. From my standpoint, from a commercial standpoint, the even more serious problem, notwithstanding the TVRO person or user, is the uplink. Right now, we are on the tighter spacing between Telstar 301 and Westar 4, as an example. We are experiencing adjacent satellite interference, that uplink interference. That means that an uplinker going into Telstar 301 is also illuminating and powering into Westar 4. And they're running 7 and 9 meter dishes, but they're also running very high powers. So this kind of a problem is going to get worse, and that's what I think is going to have the most impact on the industry from the commercial standpoint, and will probably move the FCC to do something to mitigate that particular situation. We're seeing quite a bit of complaints. And an example is they were testing 2 new satellites down on the lower end of the arc, and they were having a very difficult time, both of the two opposite companies trying to talk to both their satellites that kept illuminating the other satellite, and they were finally had to come to some agreement and transmit at one time for one satellite and transmit to another one for testing purposes, because they were parked very, very close together at that point. So between the opposite polarization plant and the FCC being pressured quite heavily by some rather large corporations like Hughes Communications, RCA, they'll probably have some effect and will affect it.
Okay, the bottom line is, what does the dealer tell his customer? My mother and father would like to buy a system. Obviously, they don't want a system any larger than they require. They live in a suburban neighborhood. There will be certain problems associated with putting a dish in the backyard. What do I tell them, Mike? They've heard of 2-degree spacing. They're a little concerned that they may run into a problem a few years down the road. So what do I tell them when they come to me and say, hey, Chris, what should we buy? Should we buy an 8-foot antenna, a 10-foot, a 12-foot?
Well, in my opinion, at that point, you are betting. You're betting that if you put in an 8-foot dish, that it will succeed. I personally have tested some dishes, 8-foot dishes, that will operate quite nicely in 2-degree spacing. I've also tested some 8-foot dishes that do not. So I think the first thing is that some of the manufacturers of the smaller apertures, it's incumbent on them to prove to the world their dish operates in this tighter spacing. Certainly someone who wants to sell a 12-foot dish is almost guaranteed, unless it's a terrible 12-foot dish, that it's going to operate fine. So I think that the bottom line comes to that point of the proper selection of a receiver, and if you put in an 8-foot dish, then you're betting that either the FCC changes its plans or orthogonal satellites go in, and if all goes well, your 8-foot dish was a good one to begin with, and it'll pass just fine. Keep in mind, this is not going to happen tomorrow. They are talking 10-year lifetimes to slowly evolve the technology. The FCC was very sensitive to the fact that they couldn't make all these changes all at once. And they've started to go from 4-degree spacing, 3-degree spacing, 2.5-degree spacing, and then eventually 2-degree spacing. But that 2-degree spacing, as far as the whole plant is concerned, is a good number of years off. So it's not going to happen tomorrow.
I think you have to realize, too, that the medium we're interested in, television, is the most resistant to interference of any of them. We're very lucky in that regard for our TVRO work. It's the other users, data users, business users, and so on, that are really concerned over this, and that's going to be the driver that will fend off some of the really tight spacing. As Mike was pointing out, we're already in trouble with the uplinks, which is of no concern to sports fans and so on. There are some other things coming along, though, in the development of detectors, high capture ratio detectors, that are going to change this radically. I have a system running now that will survive in 1.5-degree spacing on a 5-foot dish. It doesn't care about signals that are of equal strength in the passband. And it's this sort of thing that will change our regard for 2-degree spacing. So my answer to Mike's question, in view of electronic developments, is don't worry about it.
When can we expect to see?
This year.
That should make all the small dish people very, very happy, I'm sure. Peter, KLM, as a corporate decision, how does KLM view 2-degree spacing? You're arguably either number 1 or number 2 in volume in receivers in the country. I'm not sure where right now. Obviously, you must be looking at this, and at some point in time you must have been concerned and decided how receivers should be designed. I'm sure that with David Barker, he's aware of the capture ratio of demodulators. You also manufacture antennas. You had to make a decision on the size and type of antennas you built. How is KLM facing up to the 2-degree problem?
Well, from the technical standpoint, Chris, we believe that we're in good shape relative to 2-degree spacing. From the market standpoint, I think that if, in fact, 2-degree spacing becomes a reality, it is only going to enhance the business and the volume for the industry. You know, commenting about or following up on what Taylor had to say, I think that 1984 is going to be just an unbelievably spectacular year volume-wise. And in absolute numbers, I think that we are headed towards 600,000 units this year, which translates to well over $1 billion. I think that the garage or the basement business of 1979 and 1980 is in 1984 well over $1 billion, perhaps $1.4 billion. And that on a compounded growth rate is just an incredible number. I don't think the scare, as it originally was, of 2-degree spacing is going to impact that negatively, and in fact may become a very positive impact. Already there are some 120 channels available. If 2-degree spacing becomes a reality, it's plausible that there will be 220 channels available. Selection of programming becomes virtually unlimited, makes the product more desirable. The other thing that I think is going to continue to accelerate or add high-octane fuel to 1984 is, aside from the small dishes, is the fact that cost engineering and cost technology continues to be a factor. And as the price of the systems, although I think the major decrease has occurred, as the price of the systems continues to come down, the product becomes affordable by more and more people. And I think all of that translates to an enormous year for 1984. Whether we can handle it remains to be seen.
I think that's a very valid point.
I have a comment. Both Taylor and Peter have alluded to this, the concept that or the statement that it is true that our industry has matured and grown extremely sophisticated and large and run by true businessmen. I know Taylor's background quite heavily, and I think the thing I have to comment on is I want to encourage that the backyard engineer, the backyard hobbyist, the guy who feels he's not going to be able to contribute anymore. That's not true. What has changed is that that person is not going to bring the product to the market. He will develop this new black box that does wonderful and great things, and he will find that there now are many, many, many companies that will snap up his product if it's valid and does what it's supposed to do. So he'll find himself a ready market for new innovations and new designs of equipment. So it's not to say that you have to have the resources of HP or IBM behind you to develop something new in this market. By no means. I'm still convinced there's lots and lots and lots of money to be made by the lone entrepreneur who comes up with the better mousetrap and sells it to Peter, and Peter markets it for him. But you're not going to find this lone entrepreneur showing up anymore at one of the shows with his little metal box and sitting there trying to sell a 10 of them that he brought because that's all he could build the night before.
Yeah, I agree. I can recall many, many shows ago when virtually working all night the night before the show, finishing at 5 o'clock in the morning, wiring something together on a printed circuit board, catching the plane at 7 and flying into Omaha or Anaheim or wherever it was and saying, here's our prototype. And crowds of people around and everybody was excited and enthusiastic. And that's really what got this industry started.
Yes, absolutely.
There's no doubt about that. But now it is time. We do need the professional marketers, businessmen, financiers, like Peter, to take over and make the whole thing really gel and go together. Jacob, LNAs are a critical part in this whole system, and frankly, it's the LNA technology that has made home TVROs work. We were commenting last night at dinner that trying to find out who paid the most for their first LNA, and my friend Mike once again beat us all and paid $2,800 for an LNA. So any of the dealers who call you and complain that the price on your LNAs are too high, come go see Mike. I paid $1,600 for an LNA. I can buy one.
$2,800, didn't you?
Yeah, $2,800. I can buy one today for less than $300. It's come a long way.
Obviously.
Where are we going to go from here?
Well, the LNA market has gone a long way. It was technology driven, and I believe it's bound to take a few side routes as far as branching into a little bit more technology, a little bit more change into LMBs, and probably a lowering of the volume in LNCs.
That's a very good point. Why didn't LNCs catch on like perhaps most of us thought it would? What happened there?
I believe that the LNC idea had some drawbacks in marketing. A dealer and a distributor find a lot more freedom in marketing an amplifier with his choice of receiver and down converter than tying himself up with an amplifier, down converter in one enclosure and immediately having to buy a specific receiver. People are able to keep, obviously, LNAs on the shelf, while they will not be able to keep LNCs on the shelf. The degree of marketability is significantly higher, and I believe that's the driving factor. There is some other reasons, which are side reasons, that LNC are not acceptable as well as LNAs, and that regards to the I believe decrease in MTBF, or the failure rate of this critical box sitting at the focus of the antenna and exposed to weather. The down converter is usually more protected. It causes a complete system shutdown and difficult to replace an LNC once it fails with another LNC. It requires some adjustments in the receiver, while, as we know, an LNA is easily replaceable.
Are we facing the similar problems with an LMB, which for our audience is a low noise block down converter, which allows you simultaneous reception of 12 channels per polarity? Aren't we facing the same problem trying to market the LMB?
I believe that the LMB has more appeal because it's more versatile. It allows wiring of extra receivers at a lower cost. It requires, or say it differently, does not require an extra cable of tuning voltage. It's indeed a more complex assembly than an LA by itself, and obviously will have a higher failure rate, or I wouldn't use the higher failure rate, I would use the term MTV, minimum time between failures. It is more superior, I think, both from a marketeer's position to the LNC, but I do not foresee the LNB market to be close in size to the remaining LNA market. The LNA by itself will remain as the winning element, or the most common element, with the LNB taking a portion of the LNC market and probably taking and converting a portion of the LNAs into LNBs. I see the LNC market slowly reduced in size with time, on the account, of course, of the LNB.
In the conventional LNA design, they put a little device in the front end called an isolator. There are several LNA manufacturers that are now delivering lower cost, lower noise amplifiers that do not have the isolator in the front end. I've had a lot of dealers call me up and say, can we expect any problems? What are the advantages, disadvantages of having the isolator versus not having the isolator? Does CalAmp build an amplifier without the isolator in the front end?
Indeed we do, and that's what I referred in new technologies. A non-isolated amplifier would not be regarded as purely new technology, probably new circuitry. But you brought it up, and it's a very good subject to cover. We indeed manufacture an amplifier without an isolator. The key in making such a product is achieving what we call a unconditionally stable circuit, regarding mainly the first gallium arsenide FET. Once that's achieved, and if it's achieved at a low labor rate without too much effort, it becomes feasible to manufacture, and obviously the manufacturer ends up saving one of the, probably the most expensive component in the LNA, which is the isolator itself. There is some disagreements between manufacturers that make the non-isolated amplifier. In addition to us, there is at least, I believe, 2 more, as to what is the right method to test noise figure on these amplifiers. We came up with a method that I believe is conservative. As far as we know, it will be difficult to achieve through this method amplifiers that will be 80, 70 degrees flat in noise figure across the band. We find more reasonable to assume that most non-isolated amplifiers will operate with extreme noise figure variation over the band. That means they might be 70 degrees at one end while 110 degrees at the other end of the frequency band. That is the method that we employ in testing. These are the results, and obviously a product that I mentioned a moment ago would be sold as a 110 degrees, despite the fact that the majority of the frequency band would be nicely below 100 degrees. But this remains to be settled. The results from the field are very positive. There is a very good acceptance, except of the cases that, of course, you have an unstable amplifier, which could happen. In that case, you have an invalid product. When the product operates like it should, the end user has excellent results. Indeed, the 70, 80 degrees noise temperature on some portions of the band give positive results, especially when you sell it as a 120. Most end users love it.
The key to that, though, I think, is getting it unconditionally stable in all regimes of operation. Up until now, or maybe until the technology you've introduced, the problem has been there have been other companies tried to do that and spent, I can attest to personally, at least $500,000 trying to build an LNA that was unconditionally stable in all regimes. I was not able to. So the key is going to be getting the FET and the designs under control, so that the change of a dish, if it'll work on XYZ dish, but it won't work on so-and-so's dish. And I have a personal bug about this, and that is I think LNAs that do not have isolators ought to be marked so. And the reason for that is that at least it'll let you know that what you're dealing with. A lot of the LNAs that I have seen that didn't have isolators in them look like a common isolator, and that's good. I mean, I'm sure from the marketer's standpoint, there's a reason for that.
I understand. There is a necessity to mark those products separately. We do mark them. We call the non-isolated line the basic. For the matter of fact, we have protected the circuitry that we have developed, and we have a patent pending on the circuitry that we developed to stabilize, if I might say, the first FET. And the item that I feel still needs to be resolved is the method of testing, which might be resolved in conjunction with other manufacturers. I think it was brought up at a first meeting of a manufacturers association, which is trying to be set up these days. And it will be a subject that will be covered. But in principle, we mark ours, and we call them the basics. We have protected, in a way, our circuitry, and we believe that that our circuit, and I believe other people's circuit too, is designed to take every impedance, if I might say, or in simple terms, every antenna.
I think, again, the question boils down to, and I'd ask both Jacob and Mike, is should I have any concern putting a non-isolator type LNA in my mother and father's system in their backyard? Should they have any reason for concern, Jacob? Right now.
No, I don't see any problem. We have had difficulties to develop the product. We've gone through that period to create this unconditionally stable circuit. There should not be any operational penalties, if I might use that term, for using a non-isolated versus an isolated. It's perfectly all right for you to put it in your grandma's system. Yes.
Chris, TDF has entered the LNA manufacturing field.
High-tech amplifier, actually, a sister company.
Okay. High-tech, that's a non-isolator LNA.
That's correct.
It's a very small unit, very compact, very light. High-tech has obviously made a commitment to feel that their LNAs are stable, that the isolator is not required. How is High-tech doing?
Fine. I wish I could speak more knowledgeably on it. I'm not directly involved with that end of it. I do know, I'm wondering, Jacob mentioned kind of establishing standards for testing. Is that what you meant, or did you mean for marking the LNA or for specifying its noise temperature? I know we've examined some LNAs where, like he says, they tend to be less linear in their output across the band than non-isolated LNA, and we have seen some that vary tremendously across the band, and the manufacturer will choose 3 low points on the band and state that as the noise temperature of the device, which if you put it on the test equipment, that is indeed true at those frequencies, but it'll have peaks in the 140, 150 degree range. That's, I think, where the problem is, you know. Yeah.
Well, to put it in context, the reason everybody wants to drop an isolator out of the system is that you're looking at, in low quantities, $125 more for the cost of an isolator, and in high quantities, even if you're producing 10,000 of the silly things, you're still looking at $50, $60 for an isolator. And the cost penalty in noise temperature is usually half, or well, 0.1, 0.2, 0.3 dB, something like that, most
The
isolated.
cost is about 10 to 10.5 or
Okay.
10 to 15 degrees. But let me correct you, the price for isolators is lower than that these
Oh, is that
days.
right?
Yes,
Okay.
sir. We're looking at the $30 region, and that is indeed a major saving.
Yeah, well, still, that's a major portion of the cost of the unit,
Major
so.
component.
But going back to the testing or the grading or the controversy on what do you really get when you buy a non-isolator, what kind of performance you can expect. One way to test it, if I may be a little technical, is to use an isolator in front of it, connected to your noise figure machine, if I might use that term too, and get a reading. The other way is to not to include an isolator. In fact, when you include an isolator, you have to subtract for the additional noise that the isolator creates once you get your reading. The other way is not to use an isolator and to read it direct. We read it direct. We do not use an isolator at testing time, and obviously have nothing to subtract from our reading. We read a direct reading. And we also have found that most of the products do have an extreme high and an extreme low end. It could be, I have seen amplifiers at extremes 120 degrees versus 55 degrees.
Jacob, the question about the isolator is relative to the match or the impedance. Do you see the day when the antennas and the antenna feed points will be impedance rated, spec'd as 50 ohm feed, as occurs in other spectrums?
I would like to see, in fact, for a matter of fact, I was always wondering why we don't have more knowledge about what the antenna impedance is. We would have an easier life to design if to say an integrated amplifier antenna system that would significantly reduce the potential of instability if we knew more about the antenna. And Taylor, you might
Yeah,
be
well,
able
we did this in radio and radar astronomy for many years before all this came along. And the idea there was that we didn't have isolators, and you had to make the amplifier stable. So we put spoil cones or spill plates or holes. If you look at the Arecibo radio telescope, for instance, it has a gigantic hole 110 feet across down in the bottom. And that's part impedance matching. And we haven't seen that system approach in this industry yet, because people tend to build an antenna, somebody else builds the LNA, somebody else builds a down converter. And it takes a real system approach to do that, but it can be done. But it is not going to be a mix and match situation like LNAs and down converters. I'd like to point out that what Jacob's talking about in measurements are, this is all very new. These are measurements that we did not know how to make 2 years ago. The noise measurement apparatus has become very modern, very sophisticated, and very expensive. And there are arguments about how to do it. And I like the approach where you do not use the isolator. You're looking at it almost in the real world, except you don't have a real antenna impedance. The final result is, how does it work in the antenna? That's what you're interested in. And we're in a place now where consumers can see a difference of 10 and 20 degrees. You get an experienced dealer who's done a lot of installations, and they are sensitive in the 20 to 10 degree range for LNAs and system performance. Now, Chaparral, we're just putting on the market our ferrite rotators. These have some loss. We've always thought the loss in these was around 1/4 of a dB, which would add some 20 Kelvin to the front end. But in antennas, they didn't perform that way. They perform like they have less loss. And it wasn't until last week that we learned how to measure this. Now we're talking about making measurements to an accuracy of 0.05 dB routinely on a production line using people who are listening to rock and roll and only want to go out for the next break. And that's tough to do. And we have found now how to measure these and find that in fact the losses are a lot less than we had originally thought. And there were some people around who knew how to do that, and I think there are very few people now that really know how to measure noise temperature, and we're going to find out more about it as the industry gets experienced and people use them in antennas, the bottom line.
For the matter of fact, I have had some feedback from the market that comparing, let's say, an 80, 100, 120 degree marked amplifier, basic, non-isolated, with a 100 degree across the band standard product that we supply. And the result was that this 80, 100, 120 basic non-isolated has performed better across the range, which indicates that we might have indeed a built-in error, or I feel that we are grading them unknowingly and I guess unknowingly worse than they are. That means they are better than what we grade them. And we still haven't found a correction factor, and I guess the only people that enjoy it is the people that use it.
The problem with coming up with, I think, an integrated system, which is obviously the ultimate as far as a designer's standpoint for the whole system. The concept I see occurring here is that we ought to be building an LNA in a chaparral feed is really what we ought to be doing. But the last bastion of individuality is the antenna manufacturer. That's the part that anybody who can run a calculator is an antenna manufacturer. They can build, if they can bend aluminum, or they built boats before they're building antennas. And you talk about impedance matching to them, and they're having a hard time what's F over D. And so until that technology arrives even further and the antenna manufacturers start characterizing their antennas, looking at the impedance, the match levels, so that we can characterize the feeds properly. We have a catch-all feed that works very well because it's very forgiving and it's able to handle just anybody's antenna. And until that's tied down a little bit tighter, I don't think you're going to be able to match them. But as long as Jacob does his job correctly and gets that amplifier stable, there's absolutely nothing wrong with a non-isolated amplifier.
We have actually two stages of matching in here, and how does that affect the end user? How does that affect the customer, what he's seeing on his TV screen? The LNA has to match into the feed, and then the feed, of course, has to match the dish. If we assume that we're having some impedance mismatches in either of these cases, how much does it affect the reception? I mean, are we splitting hairs here?
Yes, we are, I think. Go ahead, Taylor.
You really are. It isn't an impedance problem, actually. The interface between the LNAs and the feeds is very well defined, and that's okay. I think the real thing we should address is the accuracy of dishes and the surface accuracy and how they're illuminated. And what we do at Chaparral is anybody that comes along that's going to build a dish, we tell them what the shape should be, how accurate it should be, what feed is best for it, and what carrier to noise ratio they should get out of that. We try and do the engineering for them to get them moving in the business. That assures then that you're going to have a good system match to the LNA. It's a very difficult thing, though, to explain to dish manufacturers, in most cases, why you're doing this. As the LNAs get to lower and lower noise temperatures, the design of dishes has to change, and that's why you see the move in the industry now to 0.3 F over D, because the LNA noise temperatures have gone down, the system noise temperature can go down, and by going to a deeper dish, you can actually gain in carrier to noise ratio by 0.8 of a dB over a flatter dish. It's well understood now, but it's being driven by these LNA guys who keep getting quieter and quieter.
What's the point of having an LNA that's good to 80 degrees when the dish temperature can change by 50 degrees?
Right.
Depending on the the F over D that you've got on it. So it gets lost. I mean, he's worked so very hard to give us an 80 degree LNA, which is tremendous state of the art for this technology, and then we turn around and put it on a noisy dish.
So what we're working hard to do is optimize the interaction of the feed in the dish to assure that that noise contribution is low, so Jacob and Chris won't be mad at us.
Chaparral has basically one feed, which is meant to feed dishes in the 0.375 range. Then you have your gold ring, which is meant to adapt it for lower FTD dishes.
That optimizes it at 0.3, yes.
Do you think having 2 feeds covers the range of antenna manufacturers?
Pretty much so. The intended range is about 0.42 down to 0.3 or 2.8. And anything, it's a soft trade-off. If we do produce some feeds that will be announced shortly, specials for different antennas that have different extensions in the front, it's a pretty soft trade-off. It's a good thing to do. It gains you, you're talking about 1/10 or 2/10 in carrier-to-noise ratio.
I certainly agree that perhaps one of the biggest problems facing dealers today in choosing and putting together a system is the antenna accuracy. A manufacturer can build 1 antenna very well. He can build 2, he can build 10, he can build 100. Can he build 1,000? How much variation is he going to get? Quality control becomes very, very important. I've seen dishes that look great when they went up. 3 months later, they're warped, twisted. Is this getting better? Are manufacturers starting to pay more attention to quality control?
I think they are, because the distributors and dealers are getting much more sophisticated. That you aren't dealing with individual customers who don't know what they're doing anymore. You're dealing with a very sophisticated group of people that, as I say, here are people now that are sensitive to 10 and 20 degrees in system temperature, system performance, when 2 years ago that was a difficult measurement for an LNA manufacturer to make, and now it can be made by the eyeball in the field, particularly with people going to smaller and smaller antennas.
Okay, we're quickly running out of time here. And one subject I did want to approach with Chris Kalmbach from TDF is motor drives.
Yeah, that's kind of a unique area. I think we're fortunate in that area in that we're not actually handling the signal from the satellite, which is a blessing. Maybe it's a mixed blessing. We're fortunate in that we look to the Taylor Howards and Jacob Inbars and Peter Daltons and Chris Gustafsons to build us some good equipment to pick that signal up so we can sell motor drives.
Motor drives do have their own problems, though, don't they?
They do. And the other side of the coin there is, since it's not dealing with the signal and it's probably easier for more people to do, we have more competition. So, I think we're dealing with that. As far as accuracy and 2-degree spacing goes in the motor drive business, we don't have any problems there. I mean, the mechanics of aiming the antenna, that technology existed. It's there. We don't have any problems with that. We're looking to the other folks to handle that for us.
May I suggest one of the biggest problems with motor drives is that I've noticed is they have an inordinately high price when compared to system prices these days. How do you rationalize a $750 motor drive on a $1,500 system?
It's difficult, yes. The problem, a big cost in the motor drive is the motor itself, the actuator arm. It's the electronics is, I know in our case, less than 50% of the system. The hardware cost is in the electronics, and the other is in the drive unit. And it's just one of those things that it's difficult, and there are changes being made. You have to. One of the most difficult things is you have to try to be universal. You don't know what it's going to be put on out there. You send it out the door, and you hope the guy that puts it on knows what he's doing. And in a lot of cases, you don't know whether it's going to see 50 pounds of load average or whether it's going to see 1,000, 2,000 pounds. You cross your fingers, you try to overbuild it, and see what happens.
There's an influx of offshore Taiwanese, Korean, Japanese linear actuators. Many of them are look like photocopies of Saginaw and Burr. The prices are cheaper, substantially cheaper. Is that going to bring down the price of motor drives? What's going to happen to the Saginaws and the Burrs? Are they going to be able to hang in and compete?
Oh yes. The only unit I've seen a copy from Taiwan, a copy of a Saginaw. Quality was much less, inferior to the Saginaw product, and the pricing was not that much better. I mean, I just haven't seen anything yet to compare with what's available here in the States.
I had a question I've been dying to ask someone who knows what they're doing. A lot of the newer drive systems have been incorporating the Hall effect and or a linear pot arrangement, and it seems like the Hall effect is a very tenuous design. It tends to want to go away often. You know, have they settled that technology down any better lately? It just seems like the pointing is just terrible on the Hall effect.
No, it's probably 50-50. There are people who have their favorites in both ways. Another big one is just a reed switch, a magnetic switch, which is what we're using at this time, and they're very dependable and less susceptible to interference, electrical, or damage from electrical storms, things like a Hall effect devices. We've actually gotten better performance out of a much less expensive component.
Gentlemen, thank you. We're going to have to take a break now. We'll have our next panel coming on shortly, and we will have Lloyd Covens, John Kaul, Rick Sneringer, and Peter Dalton will come in wearing his President of Space hat instead of his President of KLM hat, and hopefully we'll get some questions from the audiences. Thank you very much. I've enjoyed it.